Hello friends, today I will discuss that is the properties of XOR gate or different ways how XOR gate will apply based on different values of input, different inputs to the XOR gate. That concept we will discuss today. Okay, so let us start. That is how different properties we will apply through XOR gate. Now we see, let here a XOR with a 1, for example, a XOR with a 1, result will be, you see, it will be a complement. You see how it will we get that output a complement when a XOR with a 1. We will prove it. Actually this is the statement, we have to prove it. Now very simple way, you see, now prove it how this particular statement is true. Now we see a XOR with 1 is equal to, what happens, we apply the rule. What is the rule? Whenever we go through a XOR with b, means a complement b plus a b complement. We have already know this formula. That formula we just apply here. Very simple way. That formula we have to remember always, because that formula apply in different inputs. Whenever different XOR gate used for different purpose, different applications. Okay. Now see, a plus a XOR with 1. Here a is a, b is 1. Now we apply these values. That means here a plus, here you see a means a complement. Okay. B means 1 plus, here is a. Okay. Next is b complement dot 1 complement. Okay. Now we see what is the result. A complement dot 1 means a complement, no problem. Okay. Plus a dot 1 complement means 0. So now any value multiply with 0 or product of a into 0, obviously it will be 0. Okay. So total value is a complement. Okay. So now a direct sum with 1 is a complement. We prove it very simple way. Okay. First of all, we see what the rule of a XOR with b. If this rule we know, then there is no problem. We just are taking different values of a and b, then we apply differently. Whenever we record different formula or different operations or different inputs. Okay, just like this. Similarly, another concept also we can apply. That is, this is a XOR with 1. Similarly, a XOR with 0. Okay, a XOR with 0, that is a. We have to prove it. A XOR with 0, that is a. Same case, a XOR with 0. What is this? A is a complement dot b is 0 plus a b complement means 1. Okay. So first one is 0, obviously, because a complement, what are the values? Dot 0. So obviously this value will be 0, and a dot a, this value will be a. Okay. So total value is a 0 plus a. So that is a. Okay. So a direct sum or a XOR with 0, result will be a. Okay. In this way, you have to prove one after one. Next, third point. That is a XOR with a. Result will be what? that is 0. Very simple. Normally what happens if and A or A something different, but here is A XOR with A, that is 0. We have to prove it. Okay. So now you see A XOR with A. Very simple way. So A complement you can write into B. B is A plus A into A complement. Okay. So now we see whatever the value of A, let us consider A is 0. Okay. A is 0. A 0 means it is 1. A 0, that is 0, plus A is 0 into A complement is 1. So this will be 0, this will be 0. So 0 plus 0 is equal to 0. Here A value is 0, then result will be 0. Okay, this is the one concept. If A is 1, then what happens? A1 means A complement is 0. A means 1 plus A is 1, A complement is 0. This will be 0 and this will be 0. So 0 plus 0 is equal to 0. So whatever the value of A, definitely A XOR with A will be 0. So A XOR with A value will be 0. Okay. This is the another that is operation, we prove it. Next. Next, A XOR with A complement, it will be 1. Okay. A XOR with A complement is 1. Similarly, we prove it. A plus A complement. What is this? A complement, first one, dot A complement, second one, plus A plus A complement. Okay, because A complement B, A B complement, B is A complement. Okay. Now see what is the result. So here is A complement plus A into A complement means A. Okay. In this case, we see what is the result, what is the value of this. Suppose A is 0. Okay. Suppose A is 0. 0 complement means 1 dot 1 plus 0 into 0, that is 1 plus 0, that is 1. Okay. Whenever A is 0, that is 1. Next, if A is equal to 1, then what happens? A1 means A complement 0, A complement 0 plus A1 dot 1, that is 0 plus 1, that is also 1. Okay, that is also 1. So A plus A XOR with A complement is 1. Okay, in this way different also values we can prove it. Another way also, very easy way, we can also prove it. Like this is the one concept. Another concept also we can prove. Like A plus A XOR with A complement. What the result? We can write like A B complement. Okay, or A complement, either or case you can also take like this here in this way. Okay, so what you write A complement, here we can write A complement, second one is A complement, A complement B, A complement, B is A complement plus A B complement. B complement is already A complement complement. Okay, that is A complement plus A because A complement is A. Okay, so here what happens? If we go through this one, here A complement and A complement both, it will be A complement. Very simple way. Plus A dot A, that will also A. Okay, and A plus A complement always 1. Remember, A plus A complement always 1. You can take test anyway. Suppose A is 0, for example. A is 0. A 0 means 0, 0 complement 1. 0 plus 1 means 1. Okay. If A is 1, A1 means A complement 0 plus 1. Okay. 0 plus 1 means 1. So, A plus A complement is always 1. Don't confuse about this. A plus A complement is always 1. For example, so what happens? A plus or A complement is always 1. Okay. So, this is the another example. Similarly, you see another. That is a distributive law. We can apply distributive law. That is we can write it in this way. AB plus or XOR with a AC. AB XOR with a AC is equal to A, here B XOR with C. Okay, we have to prove it. AB XOR with AC is equal to A B XOR with C. We have to prove it. So now you see that left hand side, LHS side, we just take LHS. What is AB XOR with AC? Okay. Now you see, it means what? We know that normal concept, suppose it is X and Y. What you write? X complement or B complement, what other? As you like, your AB dot AC complement. Okay. Plus AB complement dot AC. This is the rule of XOR. Okay, this is the rule of XOR. We can define in this way. No problem. Next, AB is defined in this way, but A, according to our De Morgan's law, we can apply De Morgan's rule. De Morgan's rule is there. Okay. Whenever you use De Morgan's rule, then what happens? We can write A plus B complement is A dot B complement. A complement dot B complement. This is the rule. Okay. So this rule we apply. Okay. Reverse also like this. We can tell the reverse way, that is A complement and B complement. Reverse way also we can write A B complement is equal to, okay, A complement plus B complement. That is also true. This is the De Morgan's rule. Okay, A plus B complement, A complement dot B complement, or AB complement is equal to A complement dot A complement plus B complement. So that rule we just apply here. So second rule apply. What is A complement plus C complement? Okay, and this one what you write, that is A complement plus B complement into AC. Okay, into AC. We apply this one. Now see, we multiply A B dot A complement plus A B dot C complement, first case, plus A complement AC plus B complement AC. Okay, we also apply in this way. Then now we will solve how. You see, if we go through this one, here just swap it, swap commutative also there. FB is equal to BA, commutative rule also we can apply. Okay. So if we go through cumulative rule, then what happens? A complement AB, can write in this way. Okay. Plus, why I do it in? Because A complement A is 0. For that reason, you just write very near to that. Just to apply the cumulative law. So here is AB dot C plus A complement dot AC already there, no problem, plus B complement AC. Okay. Now see, this A complement A is 0, 0 into B plus A B C complement plus here is 0 into C plus B complement AC. Okay. Now see, it is 0 plus A B C complement. Okay. Plus here is 0 plus B complement AC. Okay. B complement AC. Now what do you write? A B C complement plus B complement AC. Okay. B complement AC. Now we see A is common. What you write? B C complement plus B complement C. Okay. So this is again we write A B XOR with C, because B C complement plus B complement C is B XOR with C. So now A multiply with A product with B complement B XOR with C. Okay. So this is our proof. So you see our original is here like this. What is this? AB XOR with AC is equal to A B XOR with C. This is our original. So now we proved AB XOR with AC is equal to A product with B XOR with C. B XOR with C. Like this, you have to prove different parts of the different properties of XOR gate. Different ways you can also define. Okay. This is the basic concept regarding on there is a XOR gate. Different properties also we apply as our requirement. Okay. Now we see what is the any other application using XOR or anything we will see. Okay. Okay. So another way also we can consider simple way, only direct value. Only consider only direct value. Direct value means suppose 1 XOR with 0. Okay. What is the value? We have to see that. What is the value of this? 1 XOR with 0. One case we will see. Another case also, that is 0. It is one case. Another case we will see 0 XOR with 1. What is the value of that? Okay. First case you see, that is 1 XOR with 0. 1 XOR with 0 means what? Means 1 dot 0 complement plus, okay, 1 complement dot 0. That is what you write? 1 dot 1 plus 1 complement 0, 0 dot 0, that is 1 plus 0, that is 1. Okay. That is 1. So if the problem is given like this, is 1 XOR with 0, the result will be 1. Okay, result will be 1. Like this also we can get the value. There is some short question, objective question also given like this. What is the result? 1 XOR with 0 or 0 XOR with 1. Similarly, second case, 0 XOR with 1. Same case, 0 into 1 complement plus 0 complement into 1. That is 0 into 0 plus 1, 0 complement is 1, 1 into 1. That is 0 plus 1. So, that is 1. Okay. That means 0 plus or XOR with 1 is equal to 1. So, now we conclude very simple way. We can also define these values. If we go through 1 XOR with 0 which is equal to 0 XOR with 1, there is no if it changes these opposite values, both will be 1. Okay, both will be 1. So, this is the one another technique or another values we can remember. If opposite values of this XOR, the value will be 1. Okay, we prove it, this one. So, another concept, if we same values, then we will see what is the value of that. Okay, if we opposite, it is okay. If same value, then what is the result? Okay, we know that, but we have to prove it, how it is coming. Okay. Now, you see, same value, 1 XOR with 1, one case, 0 XOR with 0. Then we see what is the value of this. So, first case, 1 XOR with 1, what you get? 1 dot product 1 complement plus 1 complement 1, that is 1 dot 0 plus 0 dot 1, that is 0 plus 0, that will be 0. Okay, 1 plus 1 0 plus 0, that is 0. That means 1 direct or that is XOR with 1 will be 0. So, first case we can prove it. Second case, 0 plus 0, that is XOR with 0. Then you see 0 XOR with 0 means 0 dot 0 complement plus 0 complement dot 0, 0 dot 1 plus 1 dot 0, that is 0 plus 0. So, total 0. Okay. We have to prove in this way. And here we conclude that since the same value, that is 1 XOR with 1 is equal to 0 XOR with 0 is equal to 0 value. We have to prove it in this way. Suppose prove is required. Okay, we know that opposite value is 1, same value is 0, but we have to prove in this way. Okay, so different concepts are there. Whenever we use this XOR gate, different properties also we can apply. Okay, different properties. But here another concept also we can apply. How? Here you see another concept like A complement, B complement, or something, some different ways we can also apply. You see that how it is working and what is the result of that. Okay, because you see different ways also we apply, like if is same values, like here 1 is same, 0 is same, that is A plus A, or B XOR with B, A XOR with A, B XOR with B. That means if is same, then what happens? If is same, it must be 0. We conclude that. If it is same, it must be 0, whatever the values of any inputs. If is same, that will be 0. Okay. If there is any other opposite or any other value, then it will be 1. This is the basic concept. Okay. That is opposite means A, we can write like A and A complement for opposite A for A complement. Similarly, B for B complement, opposite value, so it must be 1. Okay, it must be 1. Like this, a different test we can consider through this XOR gate. Different properties also there. We apply, we see that the properties how it is satisfied and how it will prove it as our assumption. Okay. So different concept I also explain in this particular part, that is the properties of a XOR gate. Okay. So properties of a XOR gate is very useful whenever it is necessary to define through Boolean concept. Okay, Boolean algebra. So different ways we can define. Okay, I hope all of you understand this part, this topic, and you can also use as your requirement through this XOR gate. Okay, thanks to all. Please subscribe my channel, and if any comments give to me, so we can give. Okay, thanks to all.